Students, in this video, let us look at the application part of electrochemistry. One such application of electrochemistry is batteries. Any battery or cell that we use as a source of electrical energy is basically a galvanic cell where the chemical energy of the redox reaction is converted into electrical energy. The electrochemical cell or galvanic cell used commercially must fulfill the following requirements. It should be light and compact. Its voltage should not vary appreciably during its use. It should provide power for a longer period. It should be rechargeable. These batteries are mainly classified into primary cells and secondary cells. Fuel cells are special type of galvanic cell which we discuss later. Primary cells are further classified into dry cells and mercury cells. In secondary cells, we are going to study lead storage battery and nickel cadmium storage cell. First, let us study about the dry cell. So, dry cell is a primary cell. It becomes dead over a period of time and the chemical reaction stops. It cannot be recharged or used again. In this cell, zinc cap or zinc container acts as anode and graphite rod acts as cathode. This graphite rod is surrounded by a moist paste of NH4Cl and powdered mixture of MnO2 and carbon. In dry cell, the cathodic reaction is at cathode MnO2 reacts with NH4 plus electron. Cathodic reaction is reduction, right? It forms MnOOH plus NH3. MnO2 plus NH4 plus electron gives MnOOH plus NH3. Here the oxidation state of MnO2 is plus 4 and here it is plus 3. So manganese is undergoing reduction. At anode, zinc undergoes oxidation. Zn becomes Zn2 plus 2 electrons. The Zn2 plus produced combine with NH3 liberated in cathodic reaction to form tetramine zinc 2 cation. Zn2 plus 4 NH3 gives Zn NH3 4 2 plus. Next is mercury cell. Mercury cell is mostly used in watches, video cameras, hearing aids and other compact devices. In mercury cell, the anode is zinc mercury amalgam and the cathode is a paste of mercury 2 oxide and carbon. Here electrolyte is a moist paste of KOH Zn oxide. ZnO. So at anode, the reaction is zinc amalgam ZnHg undergoes oxidation plus 2OH minus becomes ZnO plus H2O plus electrons. At cathode, HgO plus H2O liquid plus electrons gives Hg liquid plus 2OH minus, and the net reaction is zinc amalgam plus HgO ZnO plus Hg. See, this is the net reaction taking place in mercury cell. Now let us study about secondary cells. Examples for secondary cells are lead storage battery and nickel cadmium storage cell. First, let us study about lead storage battery. Lead storage battery is mostly used in automobiles. It can be recharged by passing direct current and used. It can be recharged by passing direct current and used again and again. It consists of 6 voltaic cells connected in series. In each cell, anode is made of spongy lead and cathode is a grid of lead packed with lead dioxide. The electrolyte is the aqueous solution of H2SO4, which is 38% by mass. The reaction taking place at anode is Pb plus SO4 2 minus gives PbSO4 plus electrons. At cathode, PbO2 plus SO4 2 minus plus 4H plus 2 electrons gives 2 Pb, gives PbSO4 plus 2H2O. The net reaction is Pb plus PbO2 plus 4H plus 2SO4 2 minus gives 2 PbSO4 plus 2H2O. The battery can be recharged by connecting it to an external source of direct current with voltage greater than 12 volt. It forces the electrons to flow in opposite direction, resulting in the deposition of lead on anode and PbO2 on the cathode. So during recharging at cathode, the reaction is PbSO4 plus electrons gives Pb plus SO4 2 minus. At anode, PbSO4 plus 2H2O gives PbO2 plus SO4 2 minus plus 4H plus 2 electrons. So the net reaction is net reaction is 2 PbSO4 plus 2H2O gives Pb plus PbO2 plus 4H plus 2SO4 2 minus. So this is about lead storage battery. Now let us see nickel cadmium storage cell. Nickel cadmium storage cell is another rechargeable cell. It consists of cadmium anode and the cathode made up of a metal grid containing nickel 4 oxide. These are immersed in KOH solution. At anode, cadmium plus OH minus 2OH minus, cadmium hydroxide plus 2 electrons. This is the reaction takes place at anode. At cathode, NiO2 plus 2H2O plus electrons gives NiOH twice plus OH minus. So the net reaction is cadmium plus NiO2 plus 2H2O, cadmium hydroxide plus NiOH twice. See, this is the net reaction. So this is about nickel cadmium storage cell. Now let us study about fuel cells. In recent years, the scientists have designed the cells which convert chemical energy of a fuel cell directly into electrical energy. Such cells are called fuel cells. These are the voltaic cells in which the fuels such as hydrogen, carbon monoxide, methane, etc. are used to generate electrical energy without the intervention of thermal devices like boiler, turbines, etc. One of the most successful fuel cells uses the reaction of hydrogen and oxygen to form water and is known as H2O2 fuel cell. Hydrogen and oxygen are bubbled through the electrodes into electrolyte, which is an aqueous solution of NaOH and KOH. At anode, the reaction is 2H2 plus 4OH minus gives 4H2O plus 4 electrons. At cathode, O2 gas plus 2H2O liquid plus 4 electrons gives 4OH minus. So the net reaction is two H2 gas plus O2 gas gives 2H2O liquid. See, this is the net reaction. That's all about commercial cells or batteries.